Hi girls. Just taking a look first of all at the homework. So from the two slides. A couple of you just went to get a little bit wrong with the first one. So the first one asks you for potassium and carbonate. And some of you were just oversimplifying it. And I went back to a couple of you and said, take another look or whatever, but I didn't get a chance to go to everyone, so just to go through it. Potassium, and most of you said, is +1, and carbonate is -2. So they don't balance out. You can't just write potassium carbonate. That's just not going to work. I need 2 pluses for the 2 minuses. So therefore it's got to be 2. That's the little 2, potassium, and then carbonate, CO3. So potassium carbonate is K2CO3. That's its correct formula. Okay. Magnesium then is +2. And the hydroxide ion is -1, so that's not going to work. I'm going to need 2 minuses for the 2 pluses. So the Mg is going to be 1. I want 2 of these. And because they're a complex ion, and we met that before when we were taking a look at working out a mole, we put them in a bracket and put the 2 at the bottom to say we want 2 of the whole thing. Calcium is +2, oxygen is -2, so we don't need to do anything with that one. That's CaO, and that is fine. Aluminium is +3. And sulfate is -2. Okay, so there's nothing simple we can do here. We need to have the same numbers. So what we're going to do is we're going to multiply this one by 2. So that's going to be Al2. So now we're going to have multiply that by 2, so we'll be +6. We'll multiply this one by 3 to get it to -6. So it's going to be SO4 in the bracket. And now it's going to be, that would be 3. That's -6 and +6. Aluminium sulfate, Al2, bracket SO4, bracket 3. And then sodium is +1, hydrogen carbonate is -1, so they work out nicely, so it's NaHCO3. Okay, and that had posed a little bit of a difficulty for some of you. Okay, the second part of your homework then didn't seem to pose the same level of difficulty, but I'll go through it with you now. And this is taking a look at this one. Just have my periodic table out. One sec, girls, it's in the book somewhere. Oh, it's on this page. Okay, so valency of the following. So sodium is 1, hydrogen is 1. Some of you didn't know that one. Hydrogen is 1 because it's got 1 electron, so therefore it can form 1 bond. That's max. Lithium is 1, magnesium is 2. Sulfur is also 2 because it has 6 electrons, so it forms 2 bonds to get the further 2. Iodine is 1 because that needs 1 electron. Bromine is 1. Oxygen is 2. Boron is 3. Silicon is 4. And arsenic is 3. Same as nitrogen. Okay, the one that most of you had difficulty with arsenic, which is fine. You're not going to see much of arsenic anywhere. It's number 33. We normally don't. We normally stop at number 30, unless for a few parts, of course. And then the other one that you had difficulty was hydrogen, and that's +1. It's number 1. Okay. The next little part then that we were to take a look at was electronegativity. And in terms of electronegativity, you would take a look at the electronegativity values on page 5.4. I wasn't sure what happened with some of them, to be honest. I couldn't quite figure out what your thinking was. So I'm just going to bring up here, table of electronegativities. So table of electronegativities, and then we'll just take a look at it when we're all looking at the same thing. So of course I'm not 100% sure how this shares, so I will have to stop sharing it and then I will have to share it again. So I apologize, girls, if this is a bit jumpy. Technology and me, turns out, not a massive fan. I say not a massive fan, I actually hate the thing. To be honest, can't wait to go back to regular life. I'll press stop share and then I'll just share it again. And I know this works, but I'm sure there's a shorter way of doing what I'm doing. Anyway, here is the electronegativity table. So the electronegativity values of each of the elements. So the first one that you were taking a look at, predict sodium bromide. So you're looking for the difference between sodium, which is 0.93, and bromine, which is 2.96. So 2.96 minus 0.93, and the difference between that is 2.03. That's bigger than 1.7, so that is an ionic bonded compound, okay, because it's bigger than 1.7. And the second one then is aluminium and bromine. So you're going for aluminium, which is 1.61, and bromide, which is 2.96. And the difference between them is 1.35. That is now polar covalent. Why? It's bigger than 0.4 and it's smaller than 1.7. It's polar covalent. That means they're sharing electrons, but they're not sharing them fairly. And because bromine has the bigger number, bromine is taking the unfair amount. Okay, it's me with the chocolate bar. I'm taking more than my share. Okay, bromine is taking more than their share. And the next one is nitrogen dioxide. I think this caused a confusion because it was 2, but it doesn't matter. Just taking the difference between nitrogen and oxygen. So it's 3.04 and 3.44. And the difference between them is 0.4. Because it's 0.4, you could describe it as anything. So what I would just say is it's 0.4, so it is slightly polar covalent, because it's anything above 0.4. So I would say it's slightly polar covalent, or you could say it's almost pure covalent, and either would most likely get you the marks in terms of that situation. Okay, so just that was to go through those pieces of homework, because there were a couple of issues with them. And then we're gone back and taken a look now at our PowerPoint, girls. We've taken a look as much at polar molecules as we can. There is this part in this here where it starts talking about could it be linear, etc. I'm going to need to be with you to explain that. So I could do a video on it, but it's not going to make any sense. So these particular slides that I'm going through, those 2 slides, please just ignore those 2 slides for the moment. The next one comes up all the time in the exams. It's a demonstration of polarity, and you can do it yourself at home, okay? So to demonstrate polarity, what you're going to do is you're going to take a big pen, so a pen like this. You're going to scratch it in your hair. Now, what are you doing when you do that? You're building negative charge in the pen. So this is friction, and because there's friction, you are having a transfer of electrons into the pen. So the pen will be negatively charged. You're going to switch your tap on so that there is the smallest stream of water that you can get. You don't want them dropping. You want a small little stream of water, like is in the picture here. You want the water to be dribbling out of the tap continuously. And you're just going to hold the pen close to it. And what you're going to notice is that the stream of the water is going to bend either toward the pen or away from the pen. And that is because there must be some charge in water that allows that to happen. Okay, and what charge is there in water? Well, the charge in water is the difference in electronegativities. So if you take a look at the difference in electronegativities between hydrogen and oxygen, the difference is bigger than 0.4. If you take a look at the differences between hydrogen and oxygen, take a look at hydrogen, and take a look at oxygen, look at the differences between their electronegativities, you're going to see that the difference is bigger than 0.4, so it's bigger than 0.4. So this is polar covalent. Okay. Now what does that mean? What that means is that something is taking their unfair share of electrons. And the thing that's taking their unfair share of electrons is the one with the bigger value, which is oxygen. So when you make a bond between hydrogen and oxygen, let's see if that calms down for a second, girls. My husband's mind her. When you hear her screaming, I'd say nighttime for her, so she's after her. Anyway, this is taking its unfair share of the electrons. So they're sharing these electrons, but they're not sharing them fairly. Look where I put the dots. If they were sharing them fairly, they'd be in the middle, but they're not in the middle. They're closer to the oxygen. Because they're closer to the oxygen, you think to yourself, well, what charge does an electron have? An electron has a negative charge, so that makes this what we call slightly negative. So that's delta negative. Okay, I'll just put it in a darker pen. Delta which is the symbol we use for slightly negative. It's not a full negative charge because it doesn't have all of the electrons, but it's taking more than its fair share. And because it's taking more than its fair share, hydrogen's losing out a little bit. So they're slightly positive. When you charge then your pen with negative charge, when you hold it next to the water, the hydrogens are attracted to it, but the oxygens are trying to get away from that negative charge because opposites attract. Okay, so the opposite ends. Your pen is negative, it'll be attracted to hydrogen, but it'll repel or force the oxygen away from it. And the stream of water literally bends. So you'll see it yourself if you try, and if you can't get it to work or something, it'll take 3 seconds when you come back in September to do that. We can do that, okay? So again, that's talking about what happens when you move along, and that's really as far as I want you to get this week, okay? So that's just taking a look at the shapes of molecules, the naming of molecules, and then we'll be on to ionic bonding. Now, some of this, girls, again, this part here about shape, I'm not interested in. Anything you see where it describes the linear shapes, I'm not interested in doing that because you're going to need to be physically with me for me to show you that. A little bit easier just with a visual demonstration with 2 students. It's just easier, and otherwise you're just going to stress yourselves about it. All I'm asking for is electronegativities, as I say here, and that idea that they're not sharing them equally. Okay, in terms of work, girls, the learning work is what I want you to do now for the weekend. So I want you to sit and I want you to learn everything that we've gone through. You're going to have to go back through. If you got the answers for those last questions incorrect, you're going to need to look, see what you did wrong. If you still don't understand it, you need to come and you need to let me know. Okay. They haven't fully 100% decided, but it's looking 80-20 for you girls at the moment, or 70-30, one of the two. But either way, 70% we'd say is going to be from your past exams in class, the average of them. And then the final 30 will go 15% for a final assessment. So I'll give you a final test at the end on the chapters that we've done. And it'll be an online test. We're not sure how that's going to work yet. So I will let you know in plenty of time early next week as to what they're going to look like. Whether it'll just be a worksheet or something like that. That'll be worth 15%. And the last final 15% goes for how you've engaged with the online learning platform. So basically, have you done the work that I've asked you to do? Have you submitted it reasonably on time? And if you haven't submitted it on time, have you come and let me know why? Have you been in constant communication? And there's a few of you who haven't. I mean, again, I was emailing people this morning, girls. You're going to lose your 15%. You're not going to get the full 15. I'm not going to give it if you were late consistently and constantly and you never came back and explained why. Even if you came and explained why, girls, and I feel like it's just a constant issue, like that you can get it in on a particular time, but you leave it until I chase you. That's not fully engaging. Okay, I shouldn't have to chase. But equally, there will be people who will have had proper issues. They will go to senior management and we'll be let know. Okay. And when I have more information, I'll come back and let you know. All right. So it's learning work, girls, for this weekend. And I'll see you on Monday. Okay, take care. Stop sharing now and try and stop recording.